Hello. So nice of you to join us.
Especially on a Friday.
Especially on a Friday. Thank you so much for joining us. My name is Flora and I work at Aiven, despite what my shirt says.
And my name is Marin. I work for Weaviate, despite my shirt. So we are like sisters in swag today.
Exactly. So we're hosting this little London open source data infrastructure meetup. We have a couple of talks lined up for you today.
Amazing talks, I have to say.
Yeah, that's what she said. And but we have also some sort of like house rules and stuff. So we have a code of conduct for these meetups. So if at any point in time you feel uncomfortable or you want to share something that happened and you didn't feel was right, then you can always reach out to me. There's also an email address for me on the slide if that's if you want to reach out to me. But also my colleague. So if you feel like I did something wrong, you can always reach out to my colleague, and she will not worry about saying anything, giving me feedback. So that's good. So we're two companies, right, hosting this together for you, but we're very much about the community. But also, like I get paid to do these things, so I need to tell you a little bit. We have a couple of free plans available for Redis and Postgres and MySQL for Aiven. If that's something that interests you, then please check that out. In addition to that, we also have a startup program. So if you're of the startup persuasion and you want to get some credits and possibly some leads or some interesting advice, and that's something that you could check out as well. And we're very much of the conviction that feedback is a gift. So if you like this meetup, let us know. If you didn't like the meetup or you think we could do better, then also let us know. I had 5 slides. You have 10 million slides.
Yes,
so
like a trillion.
Let's go.
That's what I'm going to ask for as well. So welcome also from our side, from the Weaviate side, from the Weaviate team. I do not have a product pitch brought with me, but I wanted to introduce today's speakers from our side who are going to enter the stage shortly after me. So you don't have to listen the whole evening to me, don't worry. Zain is in the crowd. Say hi, Zain. Say hi. Hi. Say hi, Zain. So Zain is our developer advocate. We were arguing if he's very senior, but still he doesn't want to be senior advocate, it seems. You can connect with Zain on Twitter or LinkedIn. And we have a double pack today, and I'm very excited for the talk to see both of our very awesome speakers on stage.
Only one of us will keep our jobs.
Huh?
Only one of us will keep our jobs.
Yeah, you have to rap about it.
Not the best.
So JP goes with the interesting title of Technical Curriculum Coordinator. Maybe he says something to that title later on. We will see. Feel free to connect to him as well on social media. I want to give a short community update. If you like our talk today, you can also, and if you like Weaviate, we do have a hackathon going on right now. So if you're interested in LLMs and if you like to build something amazing and you want to use like LangChain, Weaviate, go ahead, look at that hackathon. We are going to share the slides later on. Also, Zain and JP are giving free community workshops where they introduce you to Weaviate and you can follow along. So if you love the talk today, definitely join one of their workshops. And last but not least, connect to us on social media. We do have an open Slack community, and we do have a forum where you can see all the discussions going on. Oh, yeah, definitely. What happened? Okay, and that's it from my side. So I would say enjoy the talks, right?
Hi everyone, I'm Ben Gamble, and this is my talk about real-time ML and ChatGPT. So ChatGPT I'm using now because it's the most recognizable of these things. But first, there's an important warning. There will be puns in this talk. Most of them will be intentional, and I am not sorry about any of them. Yes. Anyone who's seen me talk before, you know what I mean. It will be bad. So, quick, who am I? These days I go by a bit of tech sommelier at Aiven. I have an official title, it's boring, but my real job is to pair some open source software with some closed source bits of nonsense, which is yours, and lots of code, and maybe some cheese and wine to go with it. I've worked on most things from MMO games to medical devices over a career that makes no sense to anybody, and the more I explain it, the more confusing it sounds. I even actually started a Google Glass startup, and there is a video on YouTube to prove it if you don't believe me. Yes, and because of the lovely crab, I now code a lot in Rust because it genuinely makes better jokes if you have the other crab on screen. So, quick, what is Aiven? You've heard some of it from my colleagues already, but I didn't remember they were doing that. So, first things first, hands up who knows what this is. Yep, a few of you probably saw my talk earlier. So this is the Crab Nebula. And this is our lovely logo, Rapu, and 7 of his 11 open source favorite friends. And of course, the real thing here is that the stars are the limit with open source data tooling, because we host and manage open source tools on your behalf so that you can deal with the problems that you care about without having to deal with all the infrastructure that goes with it. And a quick clarification of terms. First things first, real time. So generally real time comes under many categories, but we're talking about soft real time here. By soft real time, I mean as soon as possible with COTS software or commercial off-the-shelf software. It's kind of important to state this because you get a lot of pun back saying, it's not real time, there's no watchdog timer, there's no hard time limits on what things happen. And the short version is, in the cloud, there is no real time. We just do things as fast as we can get away with. And ChatGPT is the scariest software around, but because of what it can do and what it really unlocks. However, everything I'm saying here will work with all the other bits and pieces. You can use Vertex AI, we've tried that. Don't use Bard, it is weirdly bad. I mean, like comically bad. And I'm sure the Amazon one as well will work. The key thing here is that it's just a large language model with some configuration. It's also, they have a nice recognizable logo, so I'm going to stick with that. So let's talk about what really needs to be real time, because this is kind of like the fundamental fact here. And we've all seen things like dating apps, and you want to know that someone's matched with you now rather than having to message them 3 days later. Who here has played an online game and had waiting in a matchmaking queue for a while? Hands up. Mm-hmm. Yeah. It gets frustrating, doesn't it? And of course, if you want to make a trade online, you want to know that the price you're actually going to trade at is the one you've been promised. Because that gets really bad if you say, I will buy 50 of this, and suddenly it goes up 10x in price. Or collapses. You want to know before you buy.
Definitely, economies come and go like that.
Yes, and in the current day and age, you really want to know faster. But also, it actually comes down to more kind of touch and feel type stuff. When you leave your current Netflix show, you want to know what you should watch next soon, because otherwise you're going to bounce off. And it really matters to have a recommendation quickly. And of course, the ever classic, when you're actually doing real scale trades, there is no option but to be as fast as possible. So let's take a little bit of a scenario. Maybe you want to recommend a movie, action adventures, suitable for a 5-year-old, animals across the place. Trading, GME for Bitcoin, whatever kind of floats your boat. Or my favorite example, of course, is the taxi ride one, because we want to go from Hogwarts to Narnia with 3 people and a dragon. And that actually requires a very specialist vehicle, which means we need to be matched in the right direction at the right time with the right thing, all while waiting in the rain. So this is actually a problem you have to solve with some level of matching tools, and it gets quite complicated. Because the real problem with real time is there's a window of success. You can't do something without knowing what your real bounds are, because let's say you're trying to do something like a trade. You have a user-defined limit, like fill or kill orders last a fixed amount of time when you're doing a trade. When you're trying to get a taxi, you probably will wait for about 10 minutes before you give up on Uber and go to Lyft, and you'll wait another 5 minutes and give up on Lyft and wonder if you can get an e-bike. And these things get decreasing in time as your impatience grows. And when recommending a movie, you actually have less than a second. It can be proven before you just don't have something to see, and you'll probably go to YouTube or something else, or your next social media poison of choice. And this is actually problematic because what it really means is when you make one of these decisions, you've got to make it relatively fast, because failure is kind of a serious business here. See, when it doesn't recommend you a movie, you'll churn from that experience. You'll probably come back. But if you actually miss on a trade, there can be absolutely unlimited penalties because you as the user do not know what you bought at what price, or you can sue your kind of vendor at this point. And with a taxi, it's actually kind of more serious because this is a social contract violation. Right? You tried to do something, it's not worked, and the next time you come to that app, the other app will now be top of the list when you go to it. So there's lots of systems in place to keep you doing the same thing over and over again. So churn is a lot more damaging than you think it is when you get to these apps. So why is this hard? Because it sounds like something everything's done. You've seen Netflix recommended movies, you've definitely got a ride before. So, and it is back to that waiting problem. We know for a fact that everyone hates waiting, and the faster anything gets, the less you're willing to wait for anything else. If you know you can do one thing in real time, you expect everything else to be in real time. And as that user experience thing propagates outwards, there's no option but to make everything faster. And let's take that example again. So, you're away from home, right? We've all been away from home. It's raining. And of course, you want to, let's say, summer ride. You want to order food. We've done this on apps. They get quite complicated with those small annoying buttons, particularly if you're trying to match a meal for lots of different people. Or you want to change your flight. Hands up here who suffered a mobile change of flight on one of those apps. Hands up now who thought it was a pleasant experience. That is the correct answer. It's genuinely a horrible one because you do not actually have full control over what's going on. You don't have all the information to act on, and they're still retrieving it behind the scenes while you're doing it. Because you might think that's the best price, but you look away or you check for your credit card in your pocket and things change. Either it's gone up or it's gone down. You just don't know anymore. Or, in the case of this, I wrote this way before we had venue issues, try and find a venue for an event. You don't know how many people are going to turn up. You do not know, you have to kind of find one at a location. Venues change at the last minute. People say they have space, then they don't. And this is a serious, difficult thing. Or another fun one is anything with an app. How many people here think they could do with less apps on their phone?
Of course.
Yes.
Definitely.
How many times are you frustrated when you have to use an app, which is basically a poorly optimized mobile web page, at best? The frustration is actually quite evident, so you can't see everyone else nodding with a frustrated face, but it's genuinely true. Because what you wanted was this kind of concierge experience. You wanted to have something that got you from A to B with a relatively pleasant thing and took care of you. What it actually felt like was this. Literally a kind of massive cockpit with millions of controls from a design from many moons ago, which feels like it was done to compromise against the technology, not against user experience. Leading you to feel a bit like this. You're pressing buttons, you hope, you see what happens, and it kind of sucks. So it sucks because time's money. It really is. And we all know that if you can do things quickly, it gets better. There's a famous eBay stat about the amount of money you make by improving your checkout experience. And although the original version of this was apocryphal, it was then tested by various other groups and found to be very true. It's even more true when you look at web rankings. The slower you are, the worse you'll rank on Google by a very, very big margin. And that will just kill your website or kill your app if they decide you're too slow and you can't be ranked. And particularly with things like taxis, idle cars are pointless, happy people use the system, and you get this kind of repeating, reoccurring, and reinforcement loop going around. A bad experience drives more bad experiences. Because let's say you don't keep drivers happy because you're not giving them rides and not paying them. They're going to go off your platform, meaning your rides are going to get slower and slower, meaning users are going to leave, meaning drivers are going to leave, meaning users are going to leave. And as you can tell by these kind of cycles, in any of these things where there's matching to be done between multiple agents, it gets worse the smaller your platform is. And this kind of leads to this horrible experience. Also the idea of like UX. UX is basically what makes, and UI makes what most apps are, good or bad. We've all, particularly developers in the room, will know what developer experience looks like when it's good, and we'll know what it looks like when it's bad. I'm still not sure why we still use Git, but this seems to be the only exception that proves the rule. But we can do better. And it is worse than no experience in most cases, because confusion really drives people away. If you simply can't serve someone and you say, sorry, not available, they'll go, okay, and move on. Most people are relatively understanding if you can make that distinction early. It's when you have that Uber thing going around going, booking, booking, expanding, booking, booking. Someone found, booking, booking. No one found, booking, booking. This was me yesterday. I was not happy with this. And this is back to that social contract breach. The idea of this thing is accepted your request and said, okay, I can help. And then saying, sorry, I can't. Sucks more than saying, sorry, I can't at front. So that's the why. Let's talk about how we can solve this. So what we really want to do is translate the numeric into the human, and the human into the numeric. So this is a kind of very well-known game from the late 90s. I'm sure a few of you have played this. And famously what it did, which was really effective, was changing all the labels. So you can't really read this right now, but every time you saw a group of creatures, it didn't give you the number. It gave you a nice textual description, like hordes, a throng, zounds, a legion, which gave an emotive experience, which was far better related to how strong the creatures were than a pure number. You saw a pure number, you thought, I can take it. But when they changed it over to words, it was kind of a different experience. People were better able to kind of roughly guess if something was strong or not strong by these kind of lovely textual representations. So let's say how we do this. How do we make those user experiences good? Well, we need some historic data. We need some live data from what's going on right now. We're going to have to run some math. So we can actually start doing all the maths together. And maybe more maths, because when we're starting to get into this ML pad stuff, vector search is really complicated. You will hear more about that later. I get to say that this time. So let's think about the technology. First, we need a way to connect everything. And then we need a place to work on this data. And we decide to plug it all together. And this is where we start thinking about PubSub, and I don't mean nautical drinking establishments. I did warn you about puns. Now, there are a few different options here. RabbitMQ is a great example of why version 1 is not needed to succeed. I think they're on version 0.9.8 at the minute or something. There's NAS, which appears to have gone quiet now. I need to probably remove it from this deck, but it used to be a big thing. And MQTT, which is a lovely way to get from the edge inwards. It's also the current modern version of why IBM from now the late 90s is still a great way to get things done. And last but not least, Apache Kafka. I'm going to talk about Apache Kafka. So, and now a bit about stream processing. So what we're going to do here is we're going to take a lot of data in from the edge, we're going to do some work on it, and then we're going to spit it back out to the users. So let's say your request comes in, you do something, spit it back out. And the basics is exactly this. We take the data in, we filter it, we map it across some kind of responses, and when we send it back out again. So what we need is to gather our users' inputs, we need to sort it all out, we need to ML it up with some magic, and then we need to transmit it out to our users so we can give that experience we want to give them. But this requires a lot of data, right? The problem is that to make any decent match, you either need a ton of historic data to try and generate kind of a pattern of life thing for where you need to send drivers, what pizzas are popular, but also just things like enough users to make a sensible match. Sorry, I'm not used to having a stand microphone. And it gets complicated because suddenly you have to push all this stuff into these very narrow spaces. And the problem with all this stuff, again, is responses are limited. How do you get the right response to the user? How do you kind of focus this down so you're not trying to make a hallucinating machine learning model just give you random responses? And this is where you have to start like training your stuff all over again on what matters. So we're going to cheat. And ChatGPT or equivalents are a great way to cheat to start with. In classic days with expert systems which I used to build, you used to have to build these models yourself. You import a language model like NLTK, then you build some similarity engines, maybe a Markov chain, and you kind of hoped it all worked. With a large language model and a bit of tuning on top, you can really kind of shortcut this process and kind of take away a lot of the initial pains. But with that old school thinking as well, you can do it all together. So let's put it together. First, we need some user state. And here you'll see I'm using Apache Cassandra, if you recognize this. This is possibly the best large-scale database out there right now for transactional data. It's nearly indestructible, and Blizzard, the game studio, run absolutely every single part of all their user data on Apache Cassandra. So does Netflix as well, for that real rapid insert and extraction of just point data solutions. We're going to throw it into Kafka. We're going to run it in some Kafka streams or quick streams. Shout out to U-Turn at the back, because we'll need something that, yes, you've seen that slide, I know. Because we need something to basically run our ML suggestion on top of. And we need some history and some memory. So currently I'm using ClickHouse here, open source large scale database. You can also use Weaviate. It's absolutely awesome at this. You'll hear more later. And then what we're going to do is we're going to do a little bit of magic up front. We're going to basically tokenize what we're trying to do. We're going to look from history. We're going to throw it into ChatGPT to generate an answer. And then we're going to save that so we don't have to do it again. And then we're going to spit it out over the wire per user. And this actually becomes difficult because the problem in doing things per user is you only have a few milliseconds to make a match. Because when you start matching people and then trying to match many people together, you have to then deal with the fact that you're going in and out of the network. And then internal to your network, you only have a few milliseconds to make every single suggestion. Let's say you're playing a game and you want to match 10 people together, and it takes 10 milliseconds per match per player. The combinatorics start to explode. And you actually, this will still take you a minute to get the right match. And it's only if you can crush this initial search down really closely. Cassandra, you can get queries sub-millisecond, same with ClickHouse. But when you start getting to a very large scale, you just need to start selecting tools that can really do the crunch for you, particularly with large-scale historic search. Vector search, there are really cool tools for, and you'll hear more later. Yes. I hope you all say more about this. I am guessing wildly. So let's do this again with more dimensions. And the key thing here is loops. So when you start making matches, the biggest thing you have to do is accept the fact that humans are terrible at making continuous decisions. We love to order a taxi and cancel it. We love to change where we're going. We have this bad habit of saying we're going to play a game and then not pressing ready on a phone, or going through a tunnel midway through this whole process, and suddenly you're no longer connected. So basically, the trick with all this matching is you don't tell the user what you're really doing, and you put them in 10 queues at the same time. And this is why you need to have multiple sets of users doing multiple searches, which makes this time add up faster. Hence why we need to start using tools that can really take the speed. So let's see in action. This is just a link to open source repo, which basically builds an end-to-end solution, building your chatbot, giving you the ability to then call into ChatGPT, and just have a kind of nice chat system that can interact with all these things. This should send you to a GitHub. One of my colleagues wrote it. It's a nice Kubernetes app using Quarkus. It's just a nice starting point. I recommend having a go with it. Please ping us if you think it's interesting. Any PRs will probably be accepted. And we had an original try, so this one won't work because I definitely took it down. So if you don't have the link or it takes you to the wrong or URL doesn't work, please tell me, I'll send you the actual link to GitHub. I forgot to check which is which. Yes, I know. I suddenly realize that now. And thank you very much for listening. This is me on LinkedIn. Please add me. I will answer pretty much any question about almost any tech. I can guarantee that it will be a strange answer. Any questions?
I feel like everyone's overwhelmed with where I am.
I went rather fast, yes.
When you talk about managed open source, what
Yes.
do you do when the open source licensing model changes?
We fork it, make a new version of it, and move on. We've done this a few times now. So OpenSearch is one of our many products based off that Elastic went closed source about 2 years ago now. And so us with Amazon, our main backers of that, combined with, you remember there was a lovely Scala library called Akka, which recently went closed source. There's now a Apache Pico, which we are the main people behind, which is another fork of that originally open source project. So the general rule of open source is it's all good while it's good. We kind of actively maintain that everything we do should be open source. But the world is changing. There are those who came in with the best of intentions. We're sure they did, but commercial realities are a thing we all have to deal with eventually. I kind of wish they'd come in thinking commercial realities were a thing on day one, and then we could have all been spared the heartache of why are you doing this? But no, it's kind of a sad reality of where we are right now. But there are still plenty of us who are out there, on Apache 2 or better. Any other questions? Yes.
I do have a question. First, a small correction. Civil is actually better than Cassandra.
Closed source.
Yeah, so next
And
time.
I will happily, I will debate that happily later. Cassandra has, there are different solutions. I was chatting to the founder literally last week about this, of Scylla.
Then second question. I heard rumors, I'm just from a layman perspective, I heard rumors that you can use Lucene indexes
Yes.
as a vector search.
You can. OpenSearch does this. So the new Cassandra 5 rolls that with hierarchical small worlds inside Lucene.
So what is the difference between using a Lucene indexes as an alternative to a specialized vector search?
So I'm sure we'll get a better answer from that from the next set of speakers, but generally what happens there is three kind of main reasons. The first one is Lucene is a very nice piece of technology from quite a long time ago, written in a JVM language, which basically means you're still dealing with JVM hitches on large-scale search. The next thing there is that it's not a specialized thing. It's a bolt on top of a document store, which sort of has a reasonable layout for this sort of thing, but it's not fully optimized for actual vectorized search. New versions of Lucene are supposed to bring in SIMD optimizations, but they're still not fully there yet. When they release it, there'll be a catch-up step, but it's not quite perfect.
Sure, I mean, that doesn't
It's
matter
slow.
in practice.
It does. At scale, it really does. That's the problem. So as I was talking about the time limit you actually have to do this search and recommendation, when you start dealing with larger scale data sets into the terabytes, some of the test data sets are literally hundreds of terabytes now. If the search is something
I know who I'll talk to later after
So,
yes.
yes. No, right, I would love to talk about this more, but yes. But no, if you want to try it, please do. We host it. Go for it. I shouldn't bash it so much. But it generally works. Like most of the stuff, it all works at a certain scale. Like PG vector, great if you have a small data set. ... Cool. Any other questions? So please shout out. I genuinely can't always see hands being raised. I have severe tunnel vision, as you can probably guess by that. No?
I don't see any hands.
Well, please come ambush me later and grill me on details. I will debate C-Star and all the rest of Scylla happily with you. Don't be wrong, I'm a big fan of the technology. It has a time and place. The bifurcation is actually quite significant now with standard 5.
Right. Thank you, Ben.
Give Ben a clap.
So hi, my name is JP. I'm going to do the classic first time stand-up comic on stage thing and adjust the microphone height, because I'm not very tall. So my official title is Technology Curriculum Coordinator at Weaviate, Zain the developer advocate. But if you just think of us as smart guy, dummy, that's kind of like roughly the breakdown. So what we're going to do is a little bit different. So we gave a talk on Wednesday, which is very bottom-up, right? So we talked about vectors, vector databases, and so on. This time it's Friday afternoon. You probably, I mean, we're very grateful you're here, but I'm sure the week was long for you. So we're going to go top down, right? So we'll start with the demo. We'll show you some cool, or some stuff that we think are cool. Hopefully you agree. And then we'll talk through some of the principles about how it works, what's happening under the hood. And then Zain's going to talk through what I think is an even cooler demo. And then we'll do a little bit of internal Q&A, right? So I can ask Zain what's going on there. If he has any questions about what I've done with mine, he can ask me. And of course, from the audience, either probably at the end would probably work better, right? Because we'll cover some things through the talk. If you have any questions, please ask. That's literally my the favorite thing that I have or get to do in this position of being a Weaviate dummy. So yeah, let's get on the way, right? So Zain, can I please ask you to be my, I guess,
Be the producer's assistant.
Yes, please. So okay. So Ben talked a little bit about retrieval augmented generation. Who here has used ChatGPT? Fantastic. So I had a slide earlier in the Wednesday talk in which the options were yes and yes. And I mean, it's a little bit like that, right, for the last few months. There are some shortcomings with language models, right? And you've probably seen and experienced them. And retrieval augmented generation is a solution to that. So this demo goes through some of the possible remediations for that limitation. So Mr. Assistant, could you expand the problem statement that I have in this demo, which is that there's way too much content out there. So the background for this demo is that I am very lazy. So my solution is to not watch anything or read anything myself. And so this particular app was built because I wanted to extract content from videos and PDFs, but I'm going to show you PDFs, and get information out of it and extract it. So let's go to the source data so I can show you what options we have between different doors. So these are videos that we can draw information out of today. Would anyone like to have a guess as to what those 5 YouTube videos have in common? Don't be shy.
They're in English.
Sorry?
They're in English.
That is true, but not what I'm looking for.
Gaming.
That's true for some of them, yes, it's gaming.
We're all data scientists.
Yeah.
I don't know about that. I love Margot Robbie.
The gaming
but-
concept is used.
Okay.
They all show
Gaming
some
concept is
stuff.
used, but with
Sees everything. That's true.
So there are 2 things common about these videos. One is I've not watched any of them. And 2 is that they are all videos that were produced post ChatGPT's training end date, right? So if you ask ChatGPT about any of these videos, it would have no idea. And you're going to get one of 2 things happen. One is that it'll confidently tell you something that is incorrect. Or two is that it'll tell you something like, we don't have this information, but that's only if it can correctly identify that it is something from its frozen future, right? So let's then please go to the next tab. This is so nice having an assistant. I don't know if I kind of talked my boss about it. We'll see how it goes. All right. So the first tab is called Talk to a Video. So you saw the 5 videos earlier. I've got a pull-down menu over here, and the pre-selected video, let's just leave that, is the Margot Robbie video. I think probably the best well-known Australian at the time, or currently, which is great. And if we can expand on the what's this about something. So again, I haven't watched this video, and I was able to get GPT 3.5 to generate this summary from that video, which is like a 15-minute interview, which is really cool. So it says Margot Robbie didn't audition for the role of Barbie. That's one way to get a role, to produce the film and cast herself. Nice, you can do it. 2, made 2 requests for the Barbie movie, a slide for the bedroom, and a mermaid Barbie. When again being a producer stuff, that probably was doable. And 3, Margot immersed herself in Barbie-related research and had deep conversations with Greta Gerwig to prepare for the role. So, the one way I like to explore information from videos or types of content is to go from the summary and drill down. So then let's try and see if we can do that, and you can type into the search box. Can we say something like, it talks about deep themes, we're going to talk about what themes are explored. Yeah, sounds good. So I can tell you a little bit about what's going on under the hood before I show you, which is that the video has been ingested into Weaviate, which is the vector database that Ben very kindly plugged just a couple of times, placed in the mail. And it's going to search through the data set to find the relevant information and answer your question based on grounded truth, right? So this is very different from what happens in ChatGPT, which is that you provide some sort of query, you get an answer. But it's very difficult to understand where the data has come from. It's probably in the training data somewhere, or maybe not, it's hallucinating perhaps, don't know. But in this case, you get some data here, the answer here. Excuse me, just go and look at the answer, let's talk about that. So it talks about the fact that the video talks about the contradictory nature of being a woman, the meaning of life, identity and purpose, transformation and growth, and so on, right? So it's extracted all of this information from the video. And again, this isn't pre-programmed information. The video information is in there, but this answer has been extracted based on my question from the data, right? So it's grounded answer from the question. So if you scroll up, then look at the raw data used. This is what's happening under the hood. So what's happening is the data has been ingested, the video has been converted into text. It's been ingested into Weaviate in these small chunks. It's able to retrieve information based on my query, and Weaviate combines these truths or these chunks of text and answers my question on its basis. So if you scroll down, Zain, I can maybe show how many, or just the fact that there are multiple chunks. And I think, I show the indices there on the chunk number. And they're sorted by relevance. So as you go down the order, they're going to be less relevant, and it's being pulled in from a vector database. And I can show you a little bit about that depending on how much over time. That's what's happening under the hood. And you might think, gosh, this seems like a lot of work. How complex is it? If you scroll all the way up and click on the last tab behind the magic and just expand the code snippet, that's basically the whole query, right? Always in Python anyway. So it's like essentially 10 lines of code or so to perform all of this once your data has been ingested. And that's really the power of being able to use a vector database. So here's my second straw poll, which I think the answer is not going to be 100% like the ChatGPT question. How many of you have used a vector database before, or a vector embedding of some sort? this is amazing. That's like a pretty high percentage for what we normally get. So a vector database is a different type of database. And when we talk about a vector database, the key thing to think about is the fact that it can do what's called semantic searching or meaning-based searching. And essentially, at the very core of it, what you're doing is looking for similarity between objects and your search query. So, and that's what's happening under the hood, and it's performing your search query along with your prompt to generate the answer. Are we doing for time? I don't want to go too long.
Are we doing time?
How much more time do we have? Okay, cool.
In
So what I'll do is maybe we can go through very quickly what vectors are, and I can just run through that slide set.
You said you use a vector database. Where are the vectors? Those chunks look like words to me.
Hang on. Okay, Mr. Random person in the crowd who just asked me a question. Can you just repeat that for us?
The
Can you just move your mouse a little bit away so the sidebar goes away?
okay. The chunks you showed are words.
Yeah.
Isn't that just what a normal database can store?
Yes, random man in the crowd. That is a really good question. So yeah, the fact that the information you saw on the screen were just a series of words, and that's not a vector. What?
Move the cursor.
Keep talking.
The click is not working. Can we just go to the next slide?
Yeah.
Mr. Assistant, please, next slide, please. So a vector is just a set of numbers, right? Can you go forward, please? Like 1, 0, or a bunch of floating point numbers, or even longer floating point numbers. These are, when we talk about a vector database, and when we talk about vector embeddings, this is all it is, right? So it seems like a technical, foreign, complicated concept, and in some ways it is. But at the end of the day, this is all they are. If we can go to the next slide. If you have TikTok, you can find an amazing video that explains this stuff, by the way. And then the key thing, can we go back, please? And the key thing with vectors, though, in the context of machine learning and the modern language processing, is that they're used to represent some sort of meaning. It's not necessarily the semantic English meaning, but it's some sort of meaning, and it's represented in that way. And then this is where the disconnect kind of happens, is people say, hey, can we go to the next slide? How can numbers represent meaning? And my answer is, go to the next slide. Yes, here's an example. This hopefully is a relatable example. Many of you, hopefully, or most of you, have used some sort of color wheels before, right? Color encoding system. So RGB is one I like to use, and if you can keep going. So 25500 is red, and you can represent emerald through different 3 sets of numbers. And in this system, each number is an independent dial that you can change to change what color that you're representing, right? And if we extend that, if we visualize that concept, if we go forward, for how red, how green, how blue something is, we can plot these points in 3-dimensional space, right? And what happens is this. What you see on the screen is what happens. And what I've plotted here are points in space based on their RGB values. The colors are not plotted based on their similarity. The colors are plotted here for demonstration. So the fact that similar colors end up together is an outcome of organizing these points by their RGB values. And that's how color wheels or 3D color spheres work. And if you can go to the next slide. And if we can extend this concept to hundreds of dimensions or thousands of these dials, you can represent complex, nuanced concepts like semantic meaning of words and more, as Zain will show you later. And that's just all vectors are, and that's how they represent meaning. And this is the most kind of interesting and natural thing that it's all it is, but it's all powered by modern deep learning models. That's where magic comes from. Cool. If we can go to the next slide. Cool. So some examples. So a sentence like this: 3 people rescued off the Australian coast after yacht damaged by multiple shark attacks, can be this series of numbers. And the next few slides, tourists taking selfies and feeding bingo, vectorizing Qatari attacks. Obviously, two of the most Australian headlines you can possibly find. Sandker article and another one about Mary Earps from the World Cup just recently. So these are all different sets of vectors, and they can be representing different concepts. And what you can do then is to represent them and compare them numerically. So you can show them as a similarity matrix. My assistant is getting better at his job. This is great. And you can see that the first two examples are very similar to each other. The next set of examples are similar to each other. And as humans, we understand that because the first two examples relate to tourism in Australia, and the second two are about players, like star players, in the last World Cup, right? And this is the similarity metric that we've captured through vectorization captures that. And that's at the core of it, how vectors work, and that's how they can represent meaning, and that's why they're so useful, and that's what's been revolutionizing language processing and language models. I won't go through a lot of details in terms of vector databases and why you might want them, but the key takeaway in terms of vector databases and going from this databases is scale, speed as you scale, and the fact that you store your source data and manage it along with your embeddings, and that allows you to scale from having your object to experimentation all the way to big production scales, right? Cool, so I'm just going to stop there, at least from my part of it, and maybe I'll hand over to Zain. Cool. That's the, aha. Yeah, how you do it?
I don't have a.
I've got a,
I think so.
yeah. Do you have any questions while we're doing the handover? Yeah.
Go for it.
Yeah,
Sorry, yeah, please.
So which model did you use on your example?
So this one's done with the OpenAI embeddings, which is the ADA, that's a Loveless, I believe, 002 model. And this one, so each vector in that model is about 1,500 dimensions, which is kind of on the longer side. And yeah. Have you used them yourself?
No, I haven't used OpenAI models, but I have used open source models like Llama.
Oh, yeah.
Stuff like that, yeah.
Yeah. There's lots of models out there. I get questions about which model do I use, which one's the best. The typical answer is, so you can move my laptop if you want that, sorry.
No, so it's not the general.
Okay, cool. Sorry. Yeah, you can use most modern language models work quite well for especially non-domain specific purposes. But one thing that I encourage people to look at is on Hugging Face Hub, there's an open source benchmark or set of benchmarks for retrieval, and then that's kind of a good starting point. And some places you can fine tune models for OpenAI and whatnot, so that works. At the back, please.
How long does it take to take a transcript of a video and turn it into vectors?
That's a really good question, and it's a little bit of how long is a piece of string question. So what's happening under the hood with my thing is that I download the YouTube video, and then the first step is to get that into a transcript. So I use Whisper model to do that, and depending on the video, I think it's like for like a 20-minute video, that takes about a minute. And that's also because I've been lazy and not parallelize the process. But in terms of then vectorizing the data and ingesting into the database, it's really quick. So another demo that I often do has me ingesting about 1,000 rows of objects in the demo real time. And depending on the API, because that's a bit variable, it takes like 30 seconds or less. So it's very, very fast. No worries.
Fun thing. You're not presenting your email to me. Which could be.
Is it good?
Could be. I don't know. Let's see.
Okay. Wait.
Sorry.
A reservation at the luxury.
I wanted to clarify if I'm saying this correctly.
Yeah.
So what you did there was when you were asking the question. So did you turn the question into a vector of?
That's a really good
weights,
question.
and
Can you repeat it?
The database stores the vectors and releases in the dialog that are related to those vectors, and then you have those parts which match the original query, and then you summarize run the summarization loop over these parts, right? To produce the answer.
Yeah. So it's a two-step process, like you said. So for the first one is to turn the query into a vector, right, and find the relevant chunks. So that's step one, and that's vector search. And then the second part of it is to then get what's called basically like the context text, and combine that with the query, and then send it to a large language model. There's a couple of different ways I've been experimenting. So one is to have the user explicitly input a search query and the prompt separately. And that works okay, but from my perspective, I don't want to input two queries. So another one that I've been trying is have a prompt, and then actually ask a language model to generate a search query from that. So it's all language models all the way down. And that seems to work okay, except the language model, behaving erratically every time.
Right. Second.
Yes.
It means that I understood generally correctly. Okay. Second question is, this example is not particularly reflective of reality because the text in the video is quite small. So even for 45-minute dialogue, it's quite small. But generally, there are models that with big memory. So you can actually do the lookups with LLMs on a big chunk of text on specialized.
Yeah, like the Anthropic ones, right? Have the big context window.
Yeah. So I guess some people use the search with the LLM itself. Is there a case where, for example, using the vector search through a problem is better?
I think scale is one, right? I mean, also, there's two parts of it. One is, again, it's a database, so there's only so many things you can do in terms of just manually piping things into a language model. Zain last year, or early this year, did an example where he ingested just under 1 billion objects into a database. Pretty hard to fit that into a context window.
Not the current ones.
Not the current ones, yeah. Might need a little bit more electricity for that one. So are you guys good to go?
Yeah, we're good to go.
Cool.
Actually, for that question, there is, I think, a paper that was published that had a context size of 1 billion tokens, and that was completely insane. If you looked at the graph, it's like all the other models, this is our model. But the problem is, even if you have, let's just stay in this world, not in the billion token context LLMs. Even if you take 100,000 length of context, there's papers that have published that show that not all the tokens are equally attended to as well. So there's a paper that says that tokens at the beginning or at the end are given more importance in terms of attention. If the thing that you want to retrieve is in the middle, it doesn't give as much attention. There's also this concept of if you have underrepresented concepts in your input, the training data, then go to sleep here. Will not be good.
You go to sleep then? I hope not.
Yeah.
I see what you mean.
Yeah. So it's a question of retrieval versus fine tuning, but I think the answer is you have to do both. There's also another aspect that you look at it is from a cost perspective. What does it cost to insert something into a database and then retrieve it, as opposed to fine-tuning the model on every incremental data point? So they both have advantages and disadvantages, but I think there's a good for both. Okay, cool. Let's do it. All right. So JP had the. Ready to go?
Yeah.
Okay. Awesome. So JP talked about word vectors, taking words and representing them with vectors. What I'm going to talk a little bit about now is how you take other modalities, other media types, so images, video, audio, even smell. We don't have a model, we don't have an open source model that can do that yet, but there is research that's going on for that. But if you have a way that can translate any human understandable modality into vectors, then you can use those vectors in a vector database and you can perform search over them. Right? So this is a quick demo that we put together that will show you what that looks like. So what we've done to set this up is we've put in audio, video, images into Weaviate, and we've used an open source model from Meta called ImageFind. And essentially how this model works is that underneath the hood, it's actually 6 different models. And so if you pass it an image, it'll kind of route it through the image model. If you pass it natural language, it'll route it through the natural language model. So it's got these 6 models, which are then unified, and all of the vectors live in a unified vector space. So you could technically compare audio to video to image, and you can say, how close is this image of a dog to this chirping sound of a bird, right? Which is pretty cool. So what that enables you to do is, if you go here, if you just hit that text search button there. So my query here is the natural language query city car. And what I'm getting out are videos. If you can play this one right here, just play the audio. Turn the, yeah. Play the video there. So this one, the video has no audio. Yeah, this is video. So who thinks they understand what's going on underneath the hood here? Any thoughts? Am I encoding these into words and then matching the words?
Why don't you tell us?
Yeah. So what's actually happening here is that you're taking each one of these multimedia concepts and you're projecting it into a vector of the same dimension so that you can technically say, what is the distance between this vector and the vector of that city car word, that string, right? So you essentially have a way to do arithmetic across modalities, and not only that, but you have the ability.
Is it the same model? Because
it's different models. That's the thing. The embedding space is the same. The models are different. The dimensionality of the embedding space is the same.
Some way to translate the
yeah,
space.
That's the thing. So it's kind of like saying, I give you words, I give you audio, I give you images and video. Now they're all their own modalities. You translate them into vectors. It's almost like saying you've translated a saying into 4 different languages. How do you then compare amongst them? You have to unify them, right? And so the way that they're unified is through this loss function called contrastive loss, where you're essentially comparing positive and negative data points. So if you have the audio file of a car and the image of a car and the word car, so what they do in this particular model, you can do it in many ways. They compare all of the other modalities to positive and negative pairs of images of that modality. So that's why it's called image bind, because it's binding all the modalities through images. And that's how they go about kind of unifying the language of vectors. There's a hand up over there.
You use different models to vectorize them, basically.
Yes. So there are 6 different models that are underlying here, and so you can check it out. It's open source. So now let's do something interesting. If you hit the audio search button there, because this model understands all these modalities, you can actually go in and you can pass in a audio file. So if you go into test audio there, test audio right there on the left. Yep. And just pick any one of these, lion, roaring, dog audio. Yeah. Open that. Can you play the input query, please? Okay. So that is now the input that we're projecting into vector space, and we're saying what are the closest vectors to this, and you get back multimodal output. Whatever is closest in concept. And the cool thing about this is that whatever you have a model for, whatever you can translate into the numerical language of machines, vectors, you can then pass it into a vector database, and you can scale it up to essentially billion objects. And that's a really cool thing. So you can do this with images, with video search, and we've open sourced this where you can go ahead and spin it up. And so, yeah, if we pass in an
Are
image.
all the videos silent?
Yes, that's a good question. The video, the images, or the visual part of the video is processed separately from the audio part of the video. Those are considered 2 separate modalities. And that's actually how they train it. So they consider audio and the images to be positive pairs, and they bind those together for images and audio. So this is image to multi-search, and these images just happen to be the closest, so you don't get any other modality up here. Yeah, sure. So if you do one more, and then I wanted to talk a little bit about.
You have 3 more minutes.
Yeah. So this is the exact same functionality as what JP showed in terms of the underlying vector search is exactly the same, except now you've got all of these senses that you've vectorized using a multimodal model, and you can scale it up. And this is what I believe the future is, right? So a lot of people are excited about large language models. I'm really excited about large multimodal models because if we're thinking about a human level reasoning engine, it surely can't just be a language model. I have a son who's about 11 months. He doesn't speak yet, but he can reason across all these modalities. He can, if you give him something, he feels it, he puts it in his mouth, he smells it. There's all of these other modalities that we build a foundation off of, after which we then use language to kind of tune higher level skills. And so if we want to move forward, we have to have large scale models that can do cross-modal reasoning, cross-modal retrieval, because that's what humans are really good at. And this is getting, so this is an approximation of where we want to get. These are obviously toy examples, but if you apply them in the right domain, so for example, recommender systems for e-commerce platforms, this can potentially take us to the next level, because how do we do recommendations right now? Well, we compare what a user has interacted with in its word form. We say this is the description of an item, and these are the most similar described items. But now you can say this item looks like this, sounds like this, feels like this, and this is how it's described. And I can either process the vectors separately, or I can combine them somehow to say, across all of the senses, this is the most similar item. And so we've seen this where I like the particular feel of a burger, but I can't quantify that. But if we have a model that could quantify it, then we could integrate that into our recommender systems of the future. And Amazon is actually doing work on this. I'll release some slides later on. You can look through them. There's a paper that was released just last week where they're not combining smell and these other vectors, but they're combining image vectors with text vectors, and they're showing that if you combine them, you can actually perform much better recommendations. Awesome. So that's my small demo. Hopefully, thinking about how you can take all these modalities, project them into vector space, and then perform this cross-modal search gets us to this place where now we're thinking about multimodal reasoning, and that as the next step. A lot of bigger companies are actually moving towards this now, where OpenAI and Google are adding the computer vision modality, and then hopefully the audio modality is next. Google is actually working on a modality which can take molecules and it can embed them into this thing called an odor map, so you can have like a region of vector space which is smelly, it smells beautiful. So very interesting work going on here. Thank you.
Yeah. I noticed that neither yourself or the weird guy behind you before you didn't show any examples of how one might get started with Weaviate. Perhaps if you're learning Weaviate, what would they do?
Yeah, if I'm learning Weaviate, there's a couple of things that I would do. So we have weekly workshops where we ramble on about this stuff because I'm very excited about this. There's also a quick start guide that you can go through in 10 minutes to go from taking data, ingesting it, and then going into it. And then what else?
Oh, sorry, there's Weaviate Academy.
Sure.
Yeah.
You're answering your own question.
I don't know what that previous question is.
You just remembered.
Yeah. So Weaviate Academy is a holistic kind of set of courses. You can try to learn about vectors and how Weaviate works and so on and so forth. So if you want to get started, quick start is a great place.
There's some questions. Yeah.
Am I right in thinking that that demo is only going to work on domains for which are embedding models been trained? So it can do lions and it can do cars, but it won't do very well on late Renaissance painting.
Yes. So, but the domains are so large. It's a very large model that unless you have a application which is very niche, like let's say you're analyzing NASA images or something like that, then it won't understand it. But in order for it to understand it, you would have to fine tune the embedding model, and then it would understand that. Yeah. And then you would have to fine tune it with similarly positive and negative examples.
So in this case, the limitation is whatever you put into the database. So if you don't have images of lions, obviously a search for lions will work, but that's not because of the model. But yeah, if you have a database of 1 million images or 1 billion, then yeah, you can search through many things.
Yeah, go ahead.
How accurate is the vectorization of images and videos compared to the text? Is it the same accuracy?
Describe accuracy.
Like how, let's say you got an input of search, how related to that search images and videos be compared to the text that comes up?
Yeah, so they do some of this comparison, but they haven't quantified it really well. So for this particular model is really good at audio comparison, much better than it is at other levels of comparisons. But they do describe how they're not optimizing every modality to every other modality. So they never compared audio to text. That optimization never happened. They compared audio to images, images to text, and if you pull together the audio and the text to the images, then in doing that, the audio and the text also get pulled together. So they call these like the converging, the emergent properties that are then bounded. So the audio and the text are automatically bounded through the image. In terms of accuracy, it's a bit of a fuzzy question. Not sure how you could take this model and say, what is the recall if you were to retrieve a concept with audio, but there haven't been studies done on that. And then again, it would go back to the question, it would be a factor of whether it's in context or whether it's not been trained on it. If it's not been trained on it, you're gonna get gibberish back.
Just to follow up on that, my understanding is that if you have multimodal image, like a clip model, where you have image and text, the recall there is pretty close, and in the bind model, image bind model, that those embedding spaces or those models that convert other modalities, if that embedding space is quite close, right? Because you're binding them all to images. Like just very, very broadly, layperson speaking.
Yeah, exactly. And so in this particular one, they actually freeze the image model. The image model doesn't change. They pull all the other models together using the image model. And so the image model is quite strong here, which means that all the other models kind of get boosted up to the level of the image model, which is why they actually get really good audio level performance. And they compare it to specialized audio models, and it holds its own weight even against those specialized models. There are a couple more hands here. Yeah, go ahead.
So what I would like to know, what kind of embedding limitations you are going to add. I'm sure this is all grouping, clustering, and based on certain things.
Yeah.
The embedding is the new form of, and we have seen through ChatGPT. More or less they do the similar thing. So what I'm interested is, what kind of limitation you foresee.
For the embedding or for the vector database, which part of the
embedding? Because
for the embedding itself, so for multimodal models particularly, it's the fact that you have to have these positive and negative pairs to optimize, right? So if I said, let's say you had a model that could digitize taste, and then I said, this is an image of a lion. Now find me a positive example of this in the vector space of taste, right? What does a lion taste like? There's some modalities that don't go together. It's very hard to find positive and negative pairs. At least with the loss functions that we're using to train these models right now, the limitation is getting rich multimodal data and then finding positive and negative examples across modalities. There's some modalities that don't even work well, like what I described to you here. That would be the main limitation, I think.
Yeah. What I meant is, what's the length?
Oh, the length of the dimensions. Yeah, so I think in this particular case, it's around 1,000 dimensions. I'm not exactly sure the exact dimensionality, but I think it's they're all 1,000 dimensional. Yeah. Yeah, and so if you look at the time varying concepts like audio and video, they don't take it all. For the video vectors, they actually take 2 frames per second, and then they vectorize that, and then they squish it together. But the same thing for audio.
But technically, as well, like in terms of number of dimensions, you could have vectors of 10,000, 100,000 dimensions. It's just that it comes with cost, because if you have to compare across like 1,000, dimensions, it takes millisecond. But if you have a million, that will take you suddenly just to compare 1 to 1. Like, it's going to be a minute or so, right? But also, like the bigger the vector, basically you store them in memory. So if you have if you have 1,000 vectors of 1,000 dimensions, it takes this much. But if there were like a million, it's suddenly you're like, oh crap,
So this is slightly contradictory, how this could be applied for financial trading. Like
So this
frequency trading.
This one particularly doesn't take in time series data. There are other models, like you can look into Meta Transformer, you can look into High MMT from Carnegie Mellon. Those ones do take in time series data and they embed it. I don't think it's very good. So I don't think you would be able to get state-of-the-art performance there. They just do it. I don't think we have really good performance there. The other thing is that these models, you have 6 models that you try to combine, so the dimensionality can be small. If you have a second approach to multimodalities, you have one model that learns everything. There, the embedding, the dimensionality has to be bigger because now that one model has to encode all these concepts. So, yeah.
May I suggest that we take the rest of the questions to the other beautiful room that we have, because we also have food and refreshments and stuff. There's some more swag over there on the table. Also a laptop that's not swag. So maybe we want to, so when you're on your way out. Thank you so much for your talk, and thank you all for coming.